In this video, we're going to talk about finding the derivative of the function f of x equals 1 divided by the square root of 2x. We want to find the instantaneous rate of change. In other words, that's the derivative with respect to x at x equals 4. And at this point in the course, we haven't really talked about the power rule or the chain rule or anything like that. So in this beginning section, we're going to take a look at taking this derivative using the definition of the derivative, which is the derivative at a, f prime of a, is equal to the limit as h goes to 0, f of a plus h minus f of a all over h. And for us, the a will just be the 4, so we would just insert that in for a, and so that's what we would have. So looking at the derivative formula here, I have f of 4 plus h minus f of 4 on top. I need to simplify what that is, and so what that would entail is going to the function f, and everywhere you see an x, replace x by 4 plus h. And then for this one, we would just go to the function f where they originally told us about it, and everywhere we see an x, we would plug in this number 4 here. So when we do that, we get a pretty complicated looking expression right here. Remember, our function was 1 divided by the square root of 2x, so I have 1 divided by the square root of 2 times 4 plus h. I went and replaced the x by 4 plus h because that's what the derivative definition there told me to do. Here I went in and replaced the x by 4. So if you try to evaluate this limit right now, you'll wind up with a 0 over 0 limit, right, which is an indeterminate form. It's a mathematically meaningless expression, and in the limit it means that the limit still could come out to be any value. So you really haven't narrowed things down. When you have the 0 over 0 case, what you need to do is just try to manipulate the function that you have and see if you can come up with something new. So looking at this one, the first thing you might see is, okay, well, I've got these two fractions here. This is a big complex fraction. In other words, I have a big fraction, and in the top part I also have fractions in there. So one thing you might want to do is to get rid of the complex fraction in there. So after I do a little simplifying here to make it look a little nicer, right, all I did here was multiply the 2 through and carry out a little arithmetic there. But what I'm going to do is get a common denominator up on top here and combine this top part into one big fraction. So the common denominator here, looking at this, is just going to be the square root of 8 plus 2h minus or times the square root of 8 is what the common denominator will be. So this denominator up here, it's missing the square root 8 that this one has. So what I would do is go and multiply top and bottom by square root 8, and that's what the result would be here. This fraction has the square root 8, but it doesn't have the square root 8 plus 2h, so I would multiply top and bottom by square root 8 plus 2h. Then you can combine those two fractions. Now these two fractions have a common denominator, right? The two fractions up in the top. So what I can do is combine them, right? And I combine or subtract fractions by subtracting the numerators and keeping the same denominator, right? If they have a common denominator, which they do. And I still have the h down here on the bottom. So now the top part is at least combined into one big fraction. So what we can do is work towards dividing these two fractions here. And so sometimes it helps to see this next step if you write the bottom part as a fraction, right? It was h, which I can write anything as a fraction pretty much by putting it over 1. So I have this fraction on top and divided by this fraction on bottom, right? If you remember, to multiply fractions, what you would do is invert the one you're dividing by and change it to multiplication. So flip h over 1 over to get 1 over h, and change this to a multiplication problem. So, and then now we can actually carry out this multiplication. And all I did in this step here was to put the h over here. So these three things are multiplied in the bottom. So if you try to substitute 0 in now on top, you would wind up with 0, and on the bottom you'd have a 0 here, which would zero out everything in the bottom. So it's still a 0 over 0 indeterminate form, despite all the work that we just did to try and correct that. So again, that means you're going to have to try something else to figure out what that limit might be. In this case, a lot of times when I have square roots in there like that, especially the addition or subtraction of one, what can help is rationalizing that part of the fraction that you see here. In other words, what I'm going to try and do is get rid of all the square roots in this numerator. Okay, and how I'm going to do that is to multiply top and bottom by essentially the same expression. It's going to have the same parts of that expression over there, but joined by a different sign. Here in the original I had a subtraction. Over in this one I have addition. So, and of course to balance things out, I'm going to have to do the same in the bottom. I can't just multiply in wherever I feel like it. I have to keep it balanced out. So next you would just actually go ahead and carry out that multiplication, and in this case you get a big huge mess. You would do that by foiling out these things on the top here. Square root 8 times square root 8 give you this 8 right here. And then I would do outer times outer. That would give me this square root 8 times square root 8 plus 2h. Inner times inner would give me this negative 8 square root 8 times square root 8 plus 2h. And then last times last would give me this minus 8 plus 2h. Notice the bottom, I didn't really multiply anything out. It's kind of counterproductive to do that, because what we're hoping is that something down here will cancel out and kind of help us with that 0 over 0 situation. So as you can probably see, some nice things happen up in the top because of what we did. First off, these two terms cancel each other out, right? They're opposites, so they add up to 0. I can distribute that negative sign through the parentheses, and I wind up with 8 minus 2h there. And so, of course, I can simplify that a little bit as well by just combining the like terms that I've got. And simplify it after I've rationalized the numerator. In other words, now if you look up here, there's no square roots there at all. You can see something kind of nice happens. I have this h as a factor on top and this h as a factor on the bottom. And so what's going to happen is that I will be able to cancel out those h's, and the expression finally reduces down to this here after I erase that h down there. So that's what you would wind up with. So so now is the time something nice happened. Let's try the 0 again and see what happens there. And when you do that, when you substitute in the 0 in for h, we can see that we would get this expression, and we can simplify that a little bit just by carrying out the multiplications with the 0 there. And then out in front here, this square root 8 times square root 8 will give me this 8 right here, and then inside the parentheses I have square root 8 plus square root 8, which is just 2 square roots of 8. So it's simpler now. And then of course these 2's can be canceled out. They're a common factor between the top and the bottom. And when I do that, I wind up with the final answer, which is -1 divided by 8 times the square root of 8.